Hi, we're doing our project on the Leidenfrost effect. And so basically what it is when a liquid comes in contact with a surface that is a lot higher temperature than its boiling point, it's going to form an insulated layer of vapor right here. So as you can see in our diagram, we have this water droplet, and then this is a hot surface with our flames. And so what happens is when the water hits the surface, the boiling point of water is about 100 degrees Celsius. So if the surface is above that point, this layer of vapor right here is going to form between the water droplet and the surface, and which means that the vapor is going to create almost like a frictionless layer up between the drop. And so the drop is going to float on top of the surface almost as if it's not touching it, and so this is going to keep the drop alive for a longer amount of time. So you can see that as the surface temperature of the water increases, or the surface temperature of the surface increases, the drop life of the water also increases. And so we'll talk a little bit more in depth than that in the next diagram.
This image shows the heat transfer between the solid surface and the liquid as a function of increasing temperature above the boiling point of the water. The initial phase is called nucleate boiling, in which we see the most typical boiling, in which droplets are forming, or gas droplets are forming inside the liquid droplet and evaporating. That's further characterized afterwards by transitional boiling, which is a more violent form of boiling in which you see exploding vapor droplets inside the water droplet, which then comes to the point where we have the Leidenfrost effect at about 200 degrees Celsius above the boiling point of water, at 200 degrees Celsius, where the vapor layer forms between the water and the solid, and it has this hovering effect above the solid. And that's called film boiling. One of the most common examples of the Leidenfrost effect is demonstrated with a hot pan in water. So as you can see, as we talked about before, how the water is kind of hopping on top of the hotter surface. And that's due to that vapor insulative layer.
So you can see how there's almost no friction, which allows the water to move quite freely. And since we have the temperature of our pan really high, the water's lasting a lot longer. So for example, if we were to reduce the temperature, it would have entered into the transition phase of boiling, which you can kind of see right there, where it's just explosively vaporizing without really staying long on the surface. And then you can see the top layer isn't even really boiling at all because that surface of the pan isn't that hot. And then as it gets down to the main layer of the pan, it begins boiling, and then those little droplets on the pan are in the Leidenfrost temperature range. Yeah.
This phenomenon can be observed between any solid and liquid that have extreme temperature differences. For example, here is a man dipping his hand into liquid nitrogen, and the next slide shows an extremely hot ball bearing being submerged in cold water.